Hello and welcome to another video. Today we're going to be going over the Pandas library and specifically selecting data out of a Pandas data frame. So a Pandas data frame is like an Excel spreadsheet. In many ways it has rows and columns, and at the intersection of these rows and columns there's going to be many cells, and each cell holds data. You can also think of Pandas data frames as a series of lists or series that are going to be holding many pieces of data, kind of like a list holds many pieces of data. So the first thing we're going to need to do is, if you haven't already ever run this command, run conda install pandas or pip install pandas. Or you can do these things on just run the command without the exclamation mark and run it on the command prompt or at the command line if you're on a Mac. And that will install the packages you need. And I commented these out with the hashtag so that this won't actually run every time, because I've already run these commands. I don't know if I've mentioned this before, but you can use hashtags to write notes for yourself, comments that won't get run as code. And you can write whatever you want, notes for yourself later if you want. So after we've installed everything, we're going to need to import it. We're going to import pandas as PD, a very standard abbreviation. And so we'll run that. It may take a second. Now we can get into pandas series. A series is very similar to just a list. So we can create one by doing PD series, pass in a list of values, and then set the index equal to something, so a list of other values. And we can set it equal to populations and write populations at the bottom of our Jupyter notebook cell to print it out. And there we go. This could represent a list of, or a series of cities and their populations, perhaps. These are just made up numbers. And then at the bottom we have the data type. So this is a float, or a floating point number. And these numbers probably, you might have a note somewhere saying these numbers are like in thousands or millions. I don't know how much. Some larger amount. And so a pandas data frame is a bunch of series put together, and you can think of it that way. But so you could write out a bunch of series and put them together into a pandas data frame, or you can just download the data, which is a much more common thing to do in a much more realistic situation. So we're going to read in the Pokemon CSV, comma separated values, and we're going to put that into a data frame called DF for data frame. You may want to name your data frames something more meaningful if you have a real world situation, but for our examples, data frame will be good enough. So nothing happened, but we did, nothing was displayed, but something did happen. We wrote DF to be this Pokemon data. So there's a few ways, basic ways we can look at the data. We can do df.head, and that's going to get the first several rows. And now we can look at the data. This is a very common thing to do when you're first familiarizing yourself with a data frame or a CSV file. And so we can see all the column names and the index over here, and then all the data within that. We can also pass in a value into head that gives us a specific number of rows back, or it defaults to 5, 0 to 4. We can also do the same things with tail, but tail is going to get the bottom of the data frame. And if we just write the data frame's name, well, it'll return the whole data frame. But Jupyter Notebooks is only going to show us the top and the bottom, so that we don't have too many rows we're having to look at. Now, there are many situations where you just want to get one specific column. And one way to do that is to do data frame name dot column name. So let's try that out. And this is going to return to us a series, just like we saw above, because each of these columns is like a series. And so when returning the name column, we had all the names of the Pokemon, and this is just showing us the top and the bottom of that series because it's too long. Another way to do that is to do data frame dot name, or not dot, but use square braces, quotes, and then the name of the column. So let's try that, and that'll do the same thing for us. A cool thing we can do with the square braces and quotes around the column names is we can actually pass in a list of column names inside these square braces, so another list. And that'll return a subset of the data frame only with those particular columns. Here we're returning that subset and we're setting equal to a new data frame called subset and then looking at the head of that subset. So there we go. We just got the name and the type 1 columns, and we are just getting the head of that. Note that just if we were to just run this, it doesn't actually manipulate the data frame. It doesn't change the data frame, it just returns a subset of the values. So if you want to continue to work with that subset, you have to set it equal to something to preserve it. Another cool thing we can do is we can get a list or a series, a particular column, and we can check if it's equal to water, like the type 1. We can see if it's equal to water or anything. We can use any kind of anything you could put in an if statement we can put here. And what this is going to do is it's going to return a series of trues and falses based on whether type 1 is equal to water. At the top and the bottom we can see they're all false, but there are some other trues in the middle. And so what we can do is we can take this series of trues and falses and we can pass it into the data frame or with square braces. And what this is going to do is it's going to return all the rows where where type 1 is equal to water. And that's a very useful thing to do. So moving on from the basic ways of retrieving data, some more advanced methods is using iLook and loc. And that stands for integer location and location. So looking at iLoc first, we can do dataframe.iloc1. This is going to get the row that has index 1, which is going to be the second row. So let's check that out. It returns to us a series. You can see this second one has this name, this type, and so forth. So that's useful, but it's even more useful so we can pass in a list, kind of like what we were doing before, and get all of these rows by their integer location, which is the same as their index. So we can do that and get a series of 3 rows. We can also do slicing like we did with lists. This is going to go from 1 to 4, or we're passing in 1 to 4, and getting everything in between. Notice this actually only goes from 1 to 3. That's because this is inclusive, exclusive. So the first number is included and the second number is excluded. So that's a useful thing to be able to do. Now another thing we can do is not just, we can use a comma to separate out when we're getting rows and when we're getting columns. We can get both rows and columns at the same time. So right here we're getting the data frame iLoc column or row 1 and column at position 2, which is going to be the second row and third column. And then we're printing it out on the first line. We're printing it out because this isn't the last thing in our Jupyter Notebook cell, so it's not going to automatically print out for us. Now down here on the second line, we're also getting rows and columns, but we're getting slices of rows and columns. So everything from 1 to, remember, 2, because 3 is excluded, and then everything from 4 to 5 because 6 is excluded. And this line is the last in our Jupyter Notebook cell, so we can just write it and it'll automatically print out for us. So let's have a look at that. First, we got grass, the piece of data that's at the intersection of 1 and column 2. And then we got a subset of the data frame because we use slicing. So that's pretty cool. We can also use loc, which just stands for location. And that's going to allow you to not just use the integer positions of where everything is, but actually call columns and indexes by their names. So here we're getting at the very beginning all the way up to 5 rows, exclusive, just like we would with iloc. But now we're passing in a list of names of the columns that we want. So let's look at what that does. So we got 0 to 5, and then we got columns HP and defense. Now, if we don't want just HP and defense, we can go use a slice notation again and get everything from HP all the way up to defense, which should include attack. Yep, so we got HP all the way up to defense, including what's in between it, which is attack, again from 0 to 5. And finally, inside loc, we can do some similar stuff to what we were doing before, where we have a series, a column of the data frame, where it's checking if it's equal to fire in this case. And we're only getting the rows where this is true, where it is in fact equal to fire. And now we can see we have all the rows where type 1 is equal to fire. So that'll wrap up this lesson. I hope you get to see you in the next one. And yeah, there's plenty of example files you can look at. Hope you enjoyed the lesson.